Hi, here's where you soon. Here's a video for my senior project's second milestone. For my second milestone, mainly is about building applications for home automation systems, and it will be mainly focused on motors. So we start with this 9-gram servo motor, which I use for my last milestone. It's convenient, but kind of weak because its size, so you cannot drive something like a curtain or a blind. That's why I acquired something this bigger for RC servo. Its torque is nearly like 3 times stronger than the 9-gram servo. The next thing I do is get a stepper motor. A stepper motor also comes just like a servo. It also has gearbox within the motor, so it will be turning by step by step. And here's a little circle I built that can control the direction of the motor. And the reason to use you need to have this driver because this motor acquires larger current that Arduino cannot provide. Okay, for stepper motor, there are mainly have two different kinds. One is called bipolar. The other one, this is called unipolar. The bottom one is called bipolar. It just depends on how you drive them, and it will also affect the number of steps for complete revolution. But after testing and do some prototype on this to drive my curtain, I discovered that this motor is still too weak to drive to do anything. That's why I didn't get this one, this big one. This has like 2.5 times more torque than these small little ones. And also for this milestone, I also learned about relay. Relay is a device that can handle a switch to control a switch. Let Arduino to control a switch that does not need for the current, the high current or voltage to go through Arduino, which can likely to burn it. In this, I got two types of relay. This is just single pole, single trigger relay, and I build a LED circuit, easy LED circuit to control it with ESP8266, so I can just remotely turn the LED on and off via Wi-Fi. And this one here is a double pole, double trigger, DB-DT relay. So you can, if you look closely, it has two plugs. Then so you can control two circuits at one time. But in this case, I use this to build a polar switching circuit that will allow me to change the polar of the DC motor, which is here. This DC motor to turn the blind back or close. And for the next I'm going to show you to demonstrate the prototype I built for the motorized curtain and blind. And here is my demonstration for the motorized blind first. For this milestone, I built I ordered a smaller blind and built a frame for it. And you can see there's a curtain on the other side, so I will be able to demonstrate both of them on one single platform. And here is what I do, how I attached the servo to control the blinds. Originally, the blind was controlled by this gear with gear pulling the loop and the gear reduction kind of gadget built in there. At first, I tried to just drive these wheels with a stepper motor by it just it's too hard to turn it, so the servo I require is not powerful enough. I even tried to use this transmission bell. Again, no luck. Then I just took the entire thing off and attached the servo in there, and it works fine. Here's there's the Arduino code I wrote it to test, and here's the circuit. So you can see I attach. This is a 6 volt servo motor, but I'm able to drive it with 5 volt voltage source from Arduino. You can see I also attached the temperatures and humidity sensor on it, so you can multitask. And there's a light sensor to determine the auto mode. What I should do right now is like when it's too bright, I just set out a simple algorithm. Right now, if it's too bright, it will close it. If it's not bright enough, it will open. So like this. Yeah, my final goal is to use 2 light sensors by comparing the indoor and outdoor brightness for the function. And that's the demo for the motorized blind. The next one will be motorized curtain. Okay, here's the demo for my motorized curtain. And here's the Arduino code, and for the demo purpose I reprogrammed it to make it just go open and close whenever he hits the end. And here is the setup. You can see there's the motor is connected to the transmission timing belt, and this one end is attached to this homemade curtain, and the other end just attached to the pulley, so it can just turn freely. And because I was debating either using stepper motor or DC motor for the project, but consider that stepper motor will take some rather complicated calibration. When you attach to the new blind, you need to count exactly the length to set out the steps. So I choose to use DC motor, which is a lot easier. You give it some voltage, give it a voltage, 12 volt, and it runs. So the thing I use is this trigger, this limit trigger. So when you're triggering, it will set out the pull high or low, depends on your setting, and you will just turn via this circuit. The circuit here is a 1 double pole double trigger relay and two transistors, which is kind of dip in here to provide enough current for it to switch, so the motor can run, and it will just switch to the polar, so it will run different direction. And because it is a 12 volt DC motor, that Arduino cannot provide such voltage. That's why here I use a power supply. Turn it on. It's 12 volt. And here's how it works. When the curtain is closing, you can see there's a block. And you trigger the switch and go the other way. Currently, this is a 60 RPM motor, which is kind of slow, but well, it's a safe bet for the motor, so it doesn't go crazy all at once. And yeah, that will be my demonstration for the motorized curtain. Turn this off. And per my milestone contract, I also programmed this. This is a remote control for a tower fan. So I was able to record the output signal from this motor, from this remote control via this infrared receiver, and I was able to send out to copy the signal in order to control the tower fan. Then one issue I discovered is that this tower fan has kind of odd function, on and off. It uses the same signal to turn on the fan and also change the airflows. So if I turn it on, you'll on, but if I push it again, it'll just start changing the airflow until 3 times later it shut down. So the issue I'm facing now is how do I detecting the current state of the tower fan. One way in my research is to build a AC current sensor, something similar function to that, and to measure I'll be able to know whether it's not on or not, and to measure the different value of AC current when it's on different states. But I wasn't able to finish that in time, so that will probably be my milestone 3. And also and there will be my second milestone video. Thank you.